Finding volume using integration is an important application of calculus. There are three different methods of doing this. The first method is known as the disk method. For most volume questions, you will be given a line to rotate around, along with bounds upon which the problem is based. In this example, the area you're trying to find is within the bounds of x equals 2, y equals x squared, and the x-axis, or y equals 0. Imagine that the equation is making a full 360 degrees rotation around the line you are given. In this case, the shape looks similar to a cone. Your goal is to find the volume of that space. To do this, we go to the disk method equation. The volume equals the integral from 0 to 2 of pi times r squared dx, where r equals the equation in terms of x. If you look carefully inside the integral, you will see that this is the formula for finding the area of a circle. The disk method finds the volume by taking cross-sections of the rotated equation with thickness dx from x equals 0 to x equals 2. We plug in our knowns into the integral and solve the equation. In terms of notation, the pi is often taken outside of the integral in order to make calculations by hand easier. We find in this example that the volume of the bounded area is 32 pi over 5. In many cases, however, your bounds are not quite as simple. In this example, we want to find the area from x equals 0 to x equals 1, bounded by y equals x squared and y equals x cubed, all rotated around y equals 0. In order to do this, we must find a way to subtract the area bounded by x cubed and y equals 0 from the area bounded by x squared and y equals 0. Here's where our second method, the washer method, comes into play. In the washer method, the volume equals pi times the integral from 0 to 1 of big R squared minus little r squared times dx. Note that this is not big R minus little r squared. The washer method finds the volume in the same way that the disk method does, with one small difference. It takes the cross-sections of the rotated area with thickness dx, subtracting the area of the little r. As you can see, it looks a lot like a washer. Once again, we plug in our knowns to the formula and solve. In this case, we find the equation to be equal to 2 pi over 35 units cubed. But what if you want to find the volume of a function rotated around x equals 0? Fortunately, there are two ways to approach this kind of problem. The first way is to take the inverse of your function, solve for y, and use the washer or disk method in respect to y with thickness dy. This is simple in theory, but often leads to complicated simplifications in order to solve for y. The second way is to use our third method, the shell method. In this example, we are rotating the equation x squared around the y-axis from 0 to 2. To find the volume, we go to our shell method formula. The volume equals 2 pi times the integral from 0 to 2 of the width of our shell times the height of our shell. In order to imagine this, think about cutting a cake. Instead of cutting it into slices, we're cutting it into rings. The equations inside our formula give us the area of the rings, each with thickness dx, from 0 to 2. Finally, we plug our knowns into the formula and solve once again. The answer comes out to be 8 pi units cubed. This concludes our lesson on volume.